Okay, guys, so the next unit is 1E, and it is called the exclusion principle. Principle. And the do now question, let me ask you something. How many 3-digit numbers are not divisible by 5? So pause the video and take like a minute or so, or a couple of minutes to figure how many 3-digit numbers are not divisible by 5. Okay, so we're back. So you're like, that's a big deal. There's so many numbers. And so you say to yourself, you know what? The idea behind the exclusion principle is that maybe it would just be easier for me to first find out how many 3-digit numbers there are, and then exclude the numbers that are divisible by 5, because that would be more easier. And that's the idea. So if I tell you to find A, you find how to find like not A. So how do we deal with this? Well, first of all, how many 3-digit numbers are there? 3 digits numbers. That would be 100 to 999. How do you count those? Well, I mean, I always find it weird because I'm not really sure how many numbers there are or how you start, you end. One way you could do is shift everything back. So how many numbers are there? Personally, I'd shift everything back to 1. So 100 minus 99 to 999 minus 99. That gives me 1 to, what is that? 900. So there's 900 numbers between 100 and 999. You could have used arithmetic sequences. You could have used arithmetic sequences from last year. And you would say, okay, well, 999 is equal to, it's equal to 100 plus n minus 1 times the common difference. And the common difference, you remember, it's 1 because we're counting by ones. And then you just solve this, and you get n equals 900. It's a little more elaborate, and we're going to be doing series and sequences again. So I know that there's 900 numbers. Now the question is, how many of them are I want to know how many are not divisible by 5. But an easier thing to do might be, how many numbers are divisible by 5? Well, so what's the first number? Well, I know the first number is 100. And that's 20 times 5. And then what's the last digit I'm interested in? Well, 1,000 is not a number. 1,000 is 5 times 200. So 995 is equal to, what is that equal to? 199 times 5. So how many digits are there? So you're like, okay, 20 to 995. No, I'm sorry, 20 to 199. How many of that? So you know what? I'm going to do my little trick. 20 minus 19 to 199 to 19. What does that become? That's 1 to 180. Okay, so there's 180 numbers. It's 3-digit numbers that are divisible by 5. And so the final answer is, what is it? 900 minus 180, which equals 720. 723, 3-digit numbers not divisible by 5. And so that's the idea, the exclusion principle. Let's work on a problem. So the first problem is, you are creating let's do another number one. So the idea is, count what you aren't interested in, sorry, and subtract from the total. Okay, first example. Sorry. You have to create a 5-digit code formed by using the digits 1 to 5 only once. That does not end in 25. So the question is, how many codes can you create? So the question is, right? How many codes can you create? You say, okay, well, what do you think? Well, take a minute to think about this. Okay, welcome back. Well, the first thing I want to know is, how many 5-digit codes can I create? Well, we know already it's 5 factorial. Oh, you know what the joke is? What does that number represent? What does this number represent? And the joke is 5! Get it? Haha. Anyway, so we know there's 120 codes. And the question is, it's going to be difficult to count all the numbers that don't end in 25, but it's not going to be so difficult to count the numbers that do end in 25. So what you're going to do is, you'll make the 5 dashes. Oops. You'll make the 5 dashes, and then I'm just going to type over my dashes. And I know they're separated by multiplication because you've practiced this. This is the idea of higher level and even standard level. You practice the material, and then you come to like 1E, having practiced 1A, 1B, 1C, and 1D. So the question is, what's going in the slots? So this is for codes that end in 25, and you're like, okay, well, this has to be 5, so there's one choice here. And this last one has to be a 2, right? So that's only one choice there. So we're left with 3 digits for the first place. We're left with 2 digits for the second place, and we're left with 1 digit for the third place. So there are 6 codes that end in 25. Therefore, by the exclusion principle, 120 minus 6 equals 114. 114 codes that do not end in 25. Okay? And then the last problem is it's more like choosing things. So the problem is in the book. There's a kid. Let's call him John. I think they have another name. And no, let's call him Steve. So let's see that Steve is playing with his toys. Oops. There's 8 puzzles because he likes to play with puzzles, and there's 5 bears. He likes to play with bears. He's a weird kid. And the idea is you have to choose 4 toys. And the question is, how many ways? The question is, how many ways can he choose at least 2 bears? Now, this seems a little, so the question is, what's more, what's less? So the first thing, at least 2 bears. So you would think, okay, well, if he's choosing for a choice, he would have to choose at least 2 bears, at least, or 3 or 4. But the book makes the point that instead of doing 2 and then 3 and then 4, so the book says, you know what, you can do, so what's the first he could do? He can do, sorry. So you would do 8. So at least 2 bears. So it's if he chooses 2 bears, there's 2 puzzles times. Sorry. Times, and then if he chooses, let's see. Sorry about that. Sorry. So if he chooses 2 bears, then he has 8 choose 2 and 5 choose 2. Or, right, if he doesn't choose 2 bears, he can do 3 bears. If he does 3 bears, right? If he chooses 3 bears, then he's only doing 1 puzzle and 3 bears. Now, what's the other option? Because once again, it's at least 2 bears. He can do 3 bears. What's the last choice? Well, he can choose 4 bears. If he chooses 4 bears, what's going on here? Let's see. And let's paste. If he's choosing 4 bears, that means there's no puzzles, and there's 4 bears. Now, the idea is you're going to subtract. You're going to add all these up, and that's your total answer. Or what the book says is the other way, using. Sorry. So the idea is using the exclusion principle. Exclusion principle. First, how many ways, total ways, can he choose for a choice? Well, we know the answer to that, right? What's the answer? Well, we know it's 13, choose 4. Right? And then subtract 0 bears and 1 bear. Now, this, you may look at this and say, "Hey, Mr. Riley, like it's." I'm sorry. You might look at. Let me expound this so you can see. Sorry. You might look at this and say, "You know what, Mr. Riley, it's the same thing." But let's say I change the numbers to, 18 bears and at least 2. Then it would change. It would make a big difference. So the idea is, and we'll see this in the probability unit, that when we look at least, at most, sometimes looking at the what we don't want makes our lives a little easier. Once again, imagine that there was, imagine this wasn't 13 choose 4. Imagine it was like 30 choose 4, and he had and there were 17 bears. So the idea is, what makes your life easier? If you want to do 2 bears plus 3 bears plus 4 bears versus total bears minus 0 bears and 1 bear, I'll do it quickly. The 0 bears would be 8 choose 4, 5 choose 0. or 8 choose 3, 5 choose 1. So you can take that, the 8 choose 4 times the 5 choose 0 plus the 8 choose 3 times the 5 choose 1 and subtract that from 13 choose 4. The idea is you decide what makes your life easier. I think that's it. Work on 1E.